All right, we've already looked at the graphs of sine and cosine in section 4. We're now going to look at the rest of the 6 major trig functions. So first two I want to look at now are tangent and cotangent. Now if you remember from our SOHCAHTOA days, tangent of theta is described as opposite over adjacent. But you'll also remember that when we looked on a unit circle, it was equal to y over x. And the main definition of tangent that I want you to think about, though, is actually used that the tangent of theta is the same as the sine of theta over the cosine of theta. That'll come in a lot more handy in chapter 5, but this is a big deal to remember. So please keep that in mind. All right, if we think about tangent in terms of sine and cosine, then it's really helpful to think of what is the graph of sine going to look like. It's kind of looking like this, right? And what's the graph? So this is y equals sine theta, and we have y equals cosine theta. So if I consider what is going to happen if I'm always putting values of sine over cosine, it's probably easier to just set up a chart and think about these different things. So that's what I'm going to do at this point. So I want to have different values of theta. Then I want to have what's the sine of theta, what's the cosine of theta, what's the tangent of theta. So we'll think about things like 0. I'm going to go in degrees, but you should be able to think in radians also. 30, 45, 60, 90. So, sorry, I'm a little bit off the screen there. The sine of 0, you should know by now, is equal to 0. The cosine of 0 is 1. And if we think of tangent as sine over cosine, then that's 0. Sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2. So the tangent of 30 is 1 over the square root of 3. I'll give the decimal equivalent of that soon. Sine and cosine of 45 degrees are both square root of 2 over 2, so the tangent is 1. The sine of 60 is square root of 3 over 2, and this is 1/2. And then the sine of 90 is 1, and the cosine is 0. Whoops, I didn't put that in. The square root of 3. And this is going to be undefined because I cannot divide by 0. So just for the sake of when I'm going to plot these in something, I want to have a decimal equivalent. So if I did 1 divided by the square root of 3, I get approximately 0.577. And if I just did the square root of 3, I get approximately 1.732. Okay, so I'm going to try to pan to the side a little bit, and then we'll see if we can graph these things. All right. Okay. So we said the cosine of 0 is 0 degrees. We said, sorry, cosine. The tangent of 0 is 0 degrees. Tangent of 30 degrees is going to be 0.577. So this is 30. The cosine of 60 degrees is going to be, sorry again, 45 degrees is equal to 1. Cosine of 60 is 1.7, so things are going to jump up a little bit. And the cosine at 90 degrees is going to be undefined. It's actually going to be a vertical asymptote. The closer and closer you get to 90 degrees for tangent, the closer and closer to infinity you go. So this is actually going to go up like that. And if I were to go in the negative direction, in the second or in the fourth quadrant, excuse me, all the sine values become negative and the cosine values remain positive. So basically I take the same picture and just invert it, where the sine of negative 30 is negative 1/2, and cosine is square root of 3 over 2. So I get negative 0.577. And then the tangent of negative 45 becomes negative 1. So I'm going to get this shape that's basically going to go do things in the opposite direction. So in general, tangent has this look. I'm going to erase that and take out some of the scale and just show what it looks like. Tangent has an initial value going through the origin, and then it just repeats and repeats and repeats. Notice this is not a sinusoid. Okay, it does not look like sine or cosine. It also has places where the domain does not exist. Okay? Cosine is basically taking the reciprocal of this. So if I try to do that in a different color, anywhere that the original function was equal to 0, I'm going to have an asymptote. And anywhere that it was undefined is now going to be 0. So let's see. That's going to be asymptote. That's going to be 0. And so if I flip a big number up here, that's going to be close to 0. If I flip something close to 0, it's going to be a big number. So it actually just looks a lot like tangent, but it's going in the other direction. And instead of having zeros, it has asymptotes, and instead of having asymptotes, it has zeros. So both tangent and cotangent have this shape that you're seeing on the screen.